Hi guys, this is Hyperledger from Off the Chain, the only YouTube channel discussing blockchain and technicals. In this episode, we have Curtis Miles, is the tech lead, blockchain tech lead for IBM. First, I will show you this presentation, and then I will have a quick chat with him just for you guys. All right, so stay tuned. All right.
So my name is Curtis Miles. I am the technical lead for blockchain for IBM in Canada. And I lead what's called our blockchain garage. So our blockchain garage is like a small consultancy within IBM that is primarily focused on first-of-a-kind projects, kind of innovative things that we're doing across different organizations. I'm not the guy that you go to at IBM to start the 2-year-long projects that are going to cost you billions and billions of dollars. You have other people like that. So I do a lot of the short stuff, usually about 8 to 10 weeks. Of development to just get an idea off the ground, prove the viability of it both from a business perspective and a technical perspective, and been doing a lot of stuff around blockchain. I've been doing this for a number of years now, and it's been really interesting to see the evolution of the different types of opportunities that are coming forward on blockchain and the maturity of organizations that are starting to do some really, really cool stuff. So I'm certainly interested in the show and shares and hearing what all the things that are some of the, I'm sure just a small fraction of the things that are happening inside of the ecosystem, and then I'll share a little bit with that with you as well from my perspective. But what I wanted to do just quickly out of the gate is just level set on Hyperledger, which of course, for anybody that knows what Hyperledger is, you know, it's a bit of a misleading term because you can mean a lot of different things when you say Hyperledger. And that's because this is Hyperledger, right? Hyperledger is a project in the Linux Foundation. It is not a technology, right? It is not just one thing, right? Hyperledger is an umbrella for open source blockchain platforms that have the desire to interoperate and evolve and mature together. So, what you see up here is the breakdown of the projects inside of Hyperledger, and they fall into 2 categories. One is frameworks, and so these are blockchain platforms that you can pull down and start to run on your own because they're all open source. Anything that's in here is open source, fundamentally managed and governed by the Linux Foundation. And then the second category is a set of tools, so things that help you use some or all of those platforms better. The things that I'm going to talk about tonight are primarily Hyperledger Fabric. That's kind of where IBM spends, where we spend most of our time. We contribute very heavily to that project, and it's got a significant momentum in the enterprise blockchain space. I'd also like to touch a little bit on Hyperledger Indy, which is something that to me is a super cool technology around distributed identity. And I think that there's some serious legs behind that, and I'm seeing that pop up in a number of places, especially here in Canada, that are exciting. So we'll talk a little bit about that. But just to kind of level set, kind of going from left to right, one of the relatively new projects inside of Hyperledger is Hyperledger Burrow. And the idea of Burrow is taking the Ethereum virtual machine and running that within the context of Hyperledger, right? Of kind of the shell that is not just all about Ethereum. So if you're interested in Ethereum and how that crossover might happen of running Ethereum-based smart contracts inside of this Hyperledger-ish type of world, check out Burrow. Still fairly early in the development and lots of opportunity for people to get involved and make things happen, but pretty exciting thing. Hyperledger Fabric is a private permissioned blockchain network that is, what we talk about Hyperledger Fabric is really all about blockchain for business, right? So it's taking enterprise types of use cases of the characteristics that define how organizations want to work back and forth with each other, and addressing some of the scalability considerations of blockchain and the limitations that exist in some of the public networks, addressing the identity notion in terms of how do you know who's done what, from the area of like provenance and traceability, kind of building that into a blockchain ecosystem. We'll talk much more about that. Like I said, Hyperledger Indy distributed identity. So if anybody's heard of the Sovereign network, Hyperledger Indy is the tool base and kind of the runtime layer for the Sovereign decentralized identity network. Contributed originally by a company called Evernym. They published that and open sourced it all under Hyperledger. Aroha is another blockchain platform that is fundamentally about mobile applications. So how do you keep a copy of the ledger on your mobile device, and how does that help you interact differently? And then Sawtooth is primarily a Intel project. There's other companies that that are getting involved, and I'm seeing that a little bit more recently, but the fundamental premise there is it uses a consensus algorithm called proof of elapsed time, which makes heavy use and is dependent upon a particular type of Intel chip that will help that algorithm execute performant in a performant way. So seeing some traction around Hyperledger sawtooth. I don't talk to any customers really about that, just because it's not something that IBM is particularly involved in. But you might be interested to kind of check that out. On the tool side, I won't go through all of these, but lots of different technologies related to working with blockchain, understanding what's on the chain, how you can get solutions up and running faster, things like that. The one that I'll call out because IBM is involved and so I tend to work with this technology quite a bit is Hyperledger Composer. So it's an environment where you can very quickly and easily create a blockchain solution without getting mired in some of the deep technical stuff that you would need to kind of build it natively directly on Hyperledger Fabric. And so it abstracts a number of concepts into higher level business domains and allows you to create things very easily through some web-based tooling and try them out, rapidly iterate, and then click a button basically and have that be deployed into a Hyperledger Fabric production type of environment. So that one is getting a lot of traction, and I'm starting to see real production level solutions being built with Hyperledger Composer. So, you know, my tendency is to kind of look at a tool like that and discount it because I'm never a guy that runs through the wizard and, you know, trusts what it spits out. I always want to know, hey, but what if I want to tweak this or change this? So that was my kind of initial hesitation around Composer, but that tool has matured significantly over the past year and a half, I would say, and it's at the point now where, like I said, I'm seeing legitimate, real business opportunities being implemented with Hyperledger Composer. Explorer is the other interesting one, which is a viewer, essentially, that sits on top of primarily Fabric. I actually don't know if it works with the other platforms as well. I only use it on top of Fabric to give you a real sense of what's going on under the covers. You can see blocks popping up on the chain. You can look at the blocks. You can understand what signatures have been applied to it, what data is in the transactions, etc. So a really interesting tool as from a debugging perspective and as you're implementing to see, hey, is everything happening the way that it should be happening? You could write your own to do that as well, which is typically what I end up doing, but Explorer is a great place to start if you just want to kind of see what's happening and not just scanning Docker logs and things like that. But that's Hyperledger, right? That breakdown of these frameworks and these tools. So the next time somebody says to you, hey, do you know Hyperledger? You can say, well, I do, but what do you mean? What do you mean when you say, do you know Hyperledger? In my experience, and maybe this is my self-reflected bias, and the fact that again, I find that oftentimes we're talking about Hyperledger Fabric, but they can mean any one of these types of technologies, so keep your ear open for that. Okay, so let me break down for you the key terms and technologies that make up a Hyperledger kind of environment. And actually, after I do this, I have a choice of two things that I can talk to you about in the time that I've got. I'm interested to know whether you care more about characteristics of what makes a good Hyperledger Fabric use case and what you should look for and what you should not look for, or whether you want to just see something running and talk a little bit more about the architecture and the technical details of what a typical solution looks like. So who would be interested in more of the use case selection and criteria and how you know what makes a good blockchain use case? Okay. And how many of you would be interested in the technical side to dive in? Okay, so see more technical hands. All right, so we'll go there. We'll get into some of the details. I'll show you something that I built, which is, I like to use it as a prototypical example of a blockchain network, and then we'll kind of go a little bit deeper. All right, so let me move through this fairly quickly. Multiple companies, right? Business network, the absolute fundamental characteristic if you're thinking about Hyperledger Fabric, a business network. What are the companies that need to work together to collectively share information more effectively, reduce the friction by which they interact? Because today, the problem looks like this. These business networks exist, right? You can think about your company and the suppliers and partners and other organizations that you're interacting with. But here, today, at best, this is API calls back and forth between organizations. At worst, this is emails with Word documents attached or spreadsheets. This can be very ugly in terms of how these integrations are done. And so there's a lot of friction and there's a lot of vulnerability because any one of these parties can change their copy of what happened and pretend like something happened that didn't, or vice versa. Right? And so then it's up to the regulator or the auditor to do the forensic accounting to figure out, at the end of the month what's happened inside of this ecosystem to make sure everybody's playing by the rules. Very inefficient system, subject to fraud and vulnerability. So we replace this, and everybody's got their own copy of this ledger. So we replace this with a picture that looks like this, right? On the surface, kind of similar. But now you've got multiple copies of what has happened inside of this ecosystem spread throughout this business network. each one of these organizations is holding a copy of the ledger, which keeps track of the transactions that have been processed between the different parties. I'm simplifying here because, of course, you can get into very specific security considerations of who can see what, who has access to what on their ledger, etc. But fundamentally, it comes down to this notion of assets, which is the data that we're sharing throughout our business network. Does not need to correlate to cryptocurrency or anything like that, right? Asset is a fundamentally generic term that you model the structure of the data that you want others to see and pass around, and it can be arbitrarily complex. There's no limitation in terms of, how detailed the information can be that is shared between parties. You have smart contracts. We call it chain code in Hyperledger Fabric. That is the business logic by which all these different parties are going to interact. And the business logic exists at every point, and every organization that has a copy of that ledger also has a copy of that business logic, which means that nobody can fundamentally change the rules of how the network is operating without getting the agreement of the other parties in the network. That adds to the level of trust inside of the ecosystem, because now if I'm doing business with you, the rules are set, and I know you can't change them on me, and you know that I can't change them on you without everybody kind of agreeing, right? So that's a very fundamental concept in terms of the value proposition of Hyperledger Fabric and private permission networks in general, right? That notion of the business logic being square around. And then every time you execute one of those smart contracts, you run the chain code, which really is code at the end of the day, written in a number of different languages. Every execution of that gets written as a transaction to the ledger, and that's what is our append-only data source, right? So pretty simple concepts, but different than what you might be familiar with if you're coming more from a public blockchain platform like an Ethereum or a Bitcoin, where you have the notion of mining and you have the ledger actually existing on any number of computers out there in this wild world, maybe some guy's basement in some country in Europe that is just plugging it in and starting to validate transactions. Hyperledger Fabric, fundamentally not the case. You have a very clear understanding of who has a copy of the ledger at any given time. You can draw a really thick circle around where your data lives, right? Which is valuable for use cases like healthcare, right? Where you might be putting some interesting data on that ledger, and you care about making sure that nothing is ever going to leak outside of the Canadian borders from a legislation perspective. Right? So very different characteristics between what makes a public blockchain use case and what is a good private permission blockchain use case. I'm going to actually hold questions till the end. Okay. All right. So these are my top 5 criteria. I won't go into detail here because you said you wanted to see technical stuff. Actually, I'm not even going to cover this. Let's go ahead. You said you wanted technical stuff. But that was my top 5 criteria for blockchain.
Will any slides be available?
I can make these available. Yeah.
Okay.
Yeah. Let's do that. Okay. So I'm going to introduce a scenario to you here around processing of legal wills. And so remember what I said the number one most important concept was in Hyperledger Fabric networks? A business network, right? So this is our business network. Our business network consists of a law firm, 2 law firms actually, Able Law, Discount Law, and the government, right? So we really have 3 copies of the ledger being held in this type of scenario. And I'm not saying that this is the best possible use case for using Hyperledger Fabric, but it's something that helps us to kind of understand what's going on. So they are going to be part of that business network. This is the workflow they're going to walk through, right? We've got participants, we've got people that are going to come in as customers of the law firm. One is going to actually be named Tina, and she is a testator, which means she has a will, right? For those your fun fact of the day, a testator is somebody that actually has a will. And so she's going to register her will on blockchain. We're going to have a beneficiary, we're going to have an executor of that will, and then we're going to have the role of the government. And we're going to see what happens as we move from left to right. So we're going to create the will and register the assets. Then, unfortunately, Tina is going to die, or as I like to euphemistically say, have a change of life state. It's always difficult talking about a legal will. It's just kind of a downer. But when that change of life state occurs, we will have something that executes automatically, right? Speaking to that notion of smart contracts and the ability to be invoked when different conditions change, that's going to begin execution of the will. The executor is going to transfer the property that was outlined inside of the will. There are going to be tax obligations for the beneficiary, and then ultimately we're going to see those tax payments be recorded by the government and see that everything is whole at the end of that. Okay, so this is our kind of our dashboard for this use case. Now, one of the things I want to caution you against, whenever you do a blockchain demo on Hyperledger Fabric, don't create one dashboard that shows everything happening from that single place, because it's really easy to get confused about why blockchain when you just have one something that looks like a portal. Because if you have one interface, it's probably okay to just implement that with a database in the back. right? So I'm going to break my rule here and show you with one dashboard, but I want you to think of myself as putting on these different hats as we walk through this scenario. And each of these hats might actually have a completely different user interface or none at all, right? So everybody's got their own window into the blockchain world because none of these people necessarily need to care or know that blockchain exists, right? It's not a technology that individual end users are typically touching and feeling in a private permission case because there's no wallet that they need to hold on to, there's no ether that they need to be worried about, there's no tokens of any kind necessarily that they need to care. So you can go through life using Hyperledger Fabric blockchain in the background and never know it, right? Okay, but our scenario here starts with Tina, and the first thing that we're going to do is register Tina as a user on this network. So as we register Tina, she has now been granted a certificate, right? Identity is really important. Certificate authorities are really important in the Hyperledger Fabric world because this is how you prove the identity and the roles and responsibilities of who can do what. So Tina gets registered. I'm going to go through register. Edwin is our executor. Okay. Ben is our beneficiary. And Gary is our government authority. So hopefully the alliteration is not lost on you as we go through this and you can kind of keep track of who's who. Now you'll notice every time I did that, you saw something appear down here, right? This is my little poor man's version of the Hyperledger Explorer that I was talking about. This is showing us the blocks that are actually on chain. Every time I clicked on register, I ran a transaction. And that transaction got recorded on chain. So for example, here's my register user transaction. That's the name of the function in my chain code that I was calling to put that person on the chain. Okay? And so we'll see this grow as our scenario continues. But if we start back up at Tina, now that everybody's registered and their identity is known, we come into the will documents, we see that she has no will. Okay, so there's no will yet registered for Tina. We come into the asset section, and she has the ability to register her vehicle. So she drives a 2014 Mazda 3. So we click on register that asset. The asset's now registered. You saw a block appear. Right, there's our register asset transaction. So now Tina cannot pretend like she never registered her vehicle. Right, because that's indelibly on the chain. We can always go back and see when that happened and then it happened. And then it was Tina because it was signed by her keys. Right? Now, this is all coming in through one of those lead law firm views, so we can talk a little bit more about that later. But now that she's registered her assets, let's go ahead and create this will document. And so the will document, now in its very first version, document version 1, and we have our timestamp for when it was originally created, and you'll notice the block appeared for create will, right? That's that transaction that we executed. But the will is bare. So you can kind of think of this as being a bare bones document or a bare bones object. Remember we talked about assets. In this case, the will is an asset that is actually being registered on the chain. And so Tina can fill in some of the details. So the executor is going to be Edwin. She can identify the witness. Let's just make Gary be the witness. And now we can add some asset instructions. And so she is going to indicate that her Mazda 3 is going to be transferred to Ben when she dies. Okay. Now, I'm going to save those changes. And as I save those changes, that will document is updated. You'll notice that the most recent block also is called create will as the transaction name. And that's just because the function that I created here in chain code, you can either pass in an existing will or you can pass in a no existing will and it will update or create, right? It's up to you to define how you want to allocate your different transactions, how you want to code those in chain code. But she has just done that. Now you'll notice though that I actually have this document version 2. So the version number was updated for the will itself. Now for this part, I don't really actually have a super nice viewer, but what I'm going to do is just open up my dev tools. And when I click this retrieve will history button, first of all, let's go to my network tab. When I click on retrieve will, here's my call to retrieve the will for Tina, that's her ID. And what I'm spitting out down here is just the JSON representation of the 2 documents that came back. So for anybody that's not a coder not familiar with JSON, just ignore this part, it won't make any sense. But the idea is that because I said retrieve will history, I have been able to query the ledger and actually pull out all the variations of this will since the beginning of its lifetime. So the very first variation, of course you can see the timestamps here recorded. The very first variation is very empty, right? Because there's not a lot of info. That was that first template of a will that we created in the first place. And the second variation here is a little bit more detailed, right? It has some information in here about who witnessed this. We have the asset instruction about transferring the vehicle with a certain asset ID to Ben, etc. So this is the definition of the structure of the asset, one of the assets that we're tracking in this implementation. And so just wanted to make that point that history of what has gone on in this network is sometimes very important as you track the provenance of an asset as it changes over time, who has owned it, how it's moved between parties. Okay, so now we've got our will. I'm going to come down to Gary. Gary has the unfortunate responsibility of marking Tina as deceased. So you can imagine Gary here is stamping the death certificate, right? Something like that, where it's an official government authority. Actually, it's Tina that's going to be deceased. So we're going to mark Tina as deceased. And as we do that, you can see, okay, we've got our change of life state of Tina. We have our record being written on the chain, which actually was two things. I don't know if you saw that. Maybe the animation didn't show up. Number 9 was the transaction that Gary actually wrote, right? He marked user as deceased. Block 10 showed up automatically thereafter, which was begin will execution, right? So as soon as Tina was deceased, now we're beginning that will execution. We've got that tied together of these different transactions. And so now, if I click on Edwin, before if I had clicked on Edwin, I should have shown you that, he did not have access to any will, but because he's the executor, once Tina dies, now ownership of that will passes to him. And so we've got all that logic built into the smart contracts, again, that nobody can change without without agreement of the other parties in the business network. And the rules say that now that Edwin is the executor and Tina is deceased, now Edwin can see the will. And so Edwin sees, okay, well, I've got this to do. I've got to make sure that Ben knows that he's now the owner of this 2004 Mazda 3. If we come to Ben and we look at Ben's assets, he has no assets yet, right? Nothing has been transferred to him. He doesn't have any assets. So let's come back to Edwin and let's confirm that transfer. So this might be, hey Ben, you've got a new car. Can you tell me when you get this? And then Ben calls Edwin back, and Edwin says, okay, great, you've got the car now. I'm gonna confirm that transfer has been done, because really Edwin is on the hook for that transfer. So he confirms it, and now if we look at Ben, he's got this asset, right? Ben is now the owner of this Mazda 3. And so in this case, we've seen an asset move from party 1 to party 2, tracked on blockchain. And in fact, as that transfer was made, sure enough, a transaction was written to the ledger to say we're transferring this asset. But now, Ben has to pay the taxes on this, right? And so Gary, being the harbinger of all things government, death and taxes, right? He now can see that the tax obligations are outstanding for Ben to pay $123.45, and that the status of that tax payment is outstanding. This can be tracked on blockchain as well, right? Ben pays it, he says, I'm recording that I have paid it. Maybe this is direct integration with payment systems that are tracking kind of payers and senders, and maybe he's clicking on some government form to say that he submitted this. That payment has now been submitted. Gary can see that the payment has been submitted. He receives it, and he marks that as received. Right? So now that the assets have been transferred, right? Ben got the car, the taxes have been paid. That satisfies all the requirements for that will to have now been completely legally processed. And as a result, if we come back to Edwin's view of the will, we can see the status is now not executing, but the status is complete. Right? All of that processing back and forth between these different things going on in 13 blocks on the chain. And now in this case, every one of these blocks only had a single transaction, but if there was lots of these things going on at the same time, these transactions would be grouped into the blocks and be able to see all that progressing in parallel. Okay? So that's the story. And now, in my -2 minutes that I have left, let me just draw for you what the architecture of something like this looks like. And I'm going to cover this really quickly. I'm not even going to use this as my build slide. And you'll get these slides. The idea here is that we've got 3 copies of the ledger, right? Business network, multiple copies of the ledger. Here's law firm 1, here's law firm 3, the second law firm, and here's the government. We have these individual users, each of which is using a user interface of some kind that is fit for purpose for them to be able to do their job and their role in this network. You don't have a single one-size-fits-all portal that everybody just logs into. Probably a good indicator that you don't have a good blockchain use case if that's the case. Not always, but often. So everybody uses their user interface. They're just calling a back-end service, right? Simple REST APIs, nothing new or special about blockchain here in terms of how those users are interacting and serve their UI, calling these APIs behind the scenes. There are some keys associated with that client application that looks them up, and there are certificates that come from either external certificate authorities or Fabric certificate authority that comes out of the box, right? So you don't have to have your own certificate authority, it'll provide one for you. And then it's the client application that leverages the piece of Fabric here. This is our first kind of view into the world of Fabric. an SDK that'll plug into Java, plug into Node, that gives you access to be able to call and talk to the ledger, your copy of the ledger, which is known as a peer, right? The peer is like the box around the data structure itself. And so all that communication happens through gRPC in real time. It executes chain code, which runs in a Docker container, and that chain code interacts with the ledger and stores things inside of this world state. It's like a cached version of the data that makes it really easy to interact with. World state is a NoSQL database, right? You're familiar with CouchDB, so you get to write NoSQL queries and just kind of interact with it in that way. This chain code is propagated across the different participants, like I said, so that nobody can change the business logic unilaterally. You've got to have agreement before you could upgrade that chain code. But the chain code can change over time, right? You can continue to modify and make improvements to your business logic as long as you've got the necessary signatures from the parties involved to say, yeah, we're all agree that this is the new logic that we're gonna use, right? And all the heads are nodding because everybody's put on their digital signature on this chain code before it gets deployed. And then you've got a network level service that is not necessarily centralized. It can be decentralized across the network to make sure that all of these blocks are being written to the chain properly and to deal with the fact that they're coming in from all directions at any given time, grouping transactions into blocks, sending them back out to the participants. Okay, so I'm out of time. That is a super quick introduction to specifically Hyperledger Fabric, a little bit more generally Hyperledger as an umbrella project for blockchain technologies. And with that, I'm out.
So hi guys, this is Amel, and this is the show again, Off the Chain, live on YouTube, and I'm here with Curtis Miles, blockchain tech lead from YouTube. Alright, so Curtis Miles, blockchain lead from IBM, and thanks for coming on the show.
My pleasure.
And I just have a couple of questions to ask you before you run off. One of the main questions, I've got a lot of questions actually. Alright, so the first question would be, what's the real difference between Ethereum, right, and Hyperledger? I have to ask that question because a lot of people are saying, why don't you run Ethereum? Why are you using the Hyperledger, right?
Yep.
So we have the guy here, right?
Yeah. So the way I think about it is like this, right? Ethereum, think about it as a global network of computers that are all involved in validating transactions and basically providing computing resources to do executions of transactions in a trusted way. Okay? But it really is global. So you have no control over where your transactions are executing and where that data is flowing between all of these parties, right? And so you rely on cryptography to keep everything secure, and you rely on mining to make sure that all these transactions are only going to be recorded once and all the rest of it, right?
Yep.
In a Hyperledger Fabric network, it's fundamentally different. When you create a fabric-based application, it's a private permission network. You have a known set of organizations, not just random guys plugging their computer in the basement of their home doing some mining. Of course, that's not so much the case anymore on Ethereum. It's these big mining farms and all the rest of it. But in theory, that's what's happened, right? You can join and start to mine on the Ethereum network, no problem. In Hyperledger Fabric, you've got organizations that are saying, no, we want to have fundamental control over where these transactions are executing and therefore where the data that's part of these transactions is going to be and where it's not going to be. And so you create this private network of organizations that have been invited, right? So there's a notion of membership and there's a fundamental notion of identity because every transaction that is executed by any one of these organizations is traceable back to that organization. Yep. And so you don't have anonymity. I mean, you can still do things anonymously within the context of your business network, but you know that at least it's somebody that has been approved to be there, right? And so that notion of anonymity versus membership and the notion of this private network where you understand at any given moment where these data is and where it isn't really is a key differentiator between private permission networks, and Fabric is just one, versus a public network like Ethereum.
Good enough for me. And alright, this is more of a personal question, right? Is it worth upgrading from Hyperledger 1.1 to 1.2? Alright. Is it worth upgrading?
So I think it depends on whether or not you're going to take advantage of things like the private channel data, right? The side DB capability to make sure that you're managing kind of where data is moving throughout the network. That's a key
But before
capability.
we do that for private channels, right?
You can, if channels are meeting your requirements, then that's great, right? Then you can continue to use channels, and you don't need to take advantage of that feature in 1.2. A lot of performance enhancements though. So if you're hitting kind of performance capabilities or performance limitations, then you might find that 1.2 is where you want to go.
Okay.
In my opinion, it's always great to continue to test on the latest platforms, but you can roll out the changes to your application as you evolve your platform and as your needs change. So I wouldn't just go and upgrade it just for the fun of it. If everything is working the way that you want it to, that's great. But keeping up to date on the latest and greatest, if you're still in development, is always a good idea.
I mean, one of the problems that we already on our private beta, so we have a couple of clients already on the platform, and so that's one of the questions that was coming up in the calls is, should we upgrade? It's so cool, they just released it.
Yeah.
Well, just
and you can wait for you can wait to see as bugs are fixed and things like that. But you can also take comfort in the fact that you can upgrade and you can practice your upgrade right in your development environments, etc. And upgrade it without it actually having to change your application. Right. That's one of the new things that was added in 1.1 is the idea of capabilities. And capabilities give you the ability to swap out the new, the old platform for the new platform, do a rolling upgrade with no downtime, and then slowly take advantage of the additional features of the new platform over time. So you can get all the advantages of being on the latest and greatest, but then start to modify your application to use the new features incrementally. So something to think about.
Okay, pretty cool. So how do you build an escrow-like payment account on Fabric? Can we do that? Like, on Ethereum, we could have an escrow account, right? So can we do something similar on Fabric?
Yeah, one of the key things that you need to understand on the Fabric perspective, and this goes beyond the individual use case, is you have to think about who is holding a copy of the ledger, right? What are the companies that are running the infrastructure to maintain those ledger copies? And so if you want to do something like an escrow type of account, then you need to make sure that you've got some neutral organization that is also going to exist to hold that copy of the ledger for multiple organizations to be involved in, and to create your channel configuration so that you've got the right level of visibility between the different organizations. So definitely possible. It's not an out of the box capability that you would, hey, let me get the escrow sample and click and run it. Kind of would very much depend upon how you want to structure that use case. But you're going to want to think about who the participants are in that network and what the value is that they're providing from hosting that escrow service and how others are going to interact with it.
All right, let me give you a little bit more context for the escrow. So all the payments, internal payments happens on Fabric, but users have the ability to cash out using a different blockchain style. All right, so at the moment we have both of them token, and we are thinking, okay, maybe we should freeze the transaction on Fabric until Stellar says, hey, it's working fine, right? And so we say, okay, why don't we use something similar to escrow? Because that's what escrow do, right? That they just freeze the account until everybody's happy, then pay whichever account, whichever person. But that's talking with Stellar, right? Which takes us to how's the project going on the Hyperledger, the IntelliJ protocol that you guys have on the Hyperledger project?
For our Stellar integration, is that what you're talking about?
Yes.
So we have a product at IBM that's continuing to evolve called WorldWire, which is a global payment infrastructure that's using Fabric as well as Stellar in conjunction. We have a team that's kind of building that out. It's very active, especially in
that's not open source, right?
No, the product is not open source. No, it's built, but it is very much built on Stellar.
Okay.
So I think what you're describing is the way that I would do it and think about it, right? If you have representations of token on Stellar, and you've got representations of value being stored on Fabric as well, then understanding and managing that transaction completion identifier from Stellar that tells you that the token A has been transferred to party B, and then saying here's the proof of that. Now you've got linkability across these chains, right? And so that's really what you want to be able to handle. It's essentially like a two-phase commit type of situation between your Fabric blockchain and your Stellar blockchain, right? So as long as you keep that in mind and understand that, hey, I can only actually transfer the value. Maybe you put a pending identifier on it in Fabric, and then you transfer it, and now you come back and you know that it has been successful or whether it's failed. Working between these identifiers between both systems that prove that the transaction is completed successfully is the way to go.
I'm sure you're familiar with Hyperledger Quilt, right?
Hyperledger Quilt. To be honest, I haven't actually used Quilt. We don't use it internally at IBM because we built our own infrastructure to be able to stitch some things together. But
I think we use the same. We build our own actually.
Yeah.
The all Stellar. We used to have a couple of blockchains that we removed now. We used to have our IOTAs as well.
Oh, okay.
We tested that. We tested Corda before we went to Stellar.
Mhm.
But and now it's really getting the the communication to be secured. So we were looking to our authentication for Kerberos, also other APIs. And one thing I saw in the diagram that I was not aware of was from the client API, from the client's SDK. There's a security layer. Right, so it's not just certificates now coming from to Fabric CA, but there's another, I think another piece there that you had on your diagram.
Yeah, so I kind of separate out the notion of authentication, with respect to an individual that's logging into some application.
Mm-hmm.
That does not need to be one and the same as the set of certificates that that application layer is now communicating with to the blockchain. Right, so you can have separation. You can put them together, right? You can use the Fabric CA with attribute-based access control tied to your LDAP server. If you've got kind of an integrated infrastructure for managing that, but you don't have to, right? You can say, hey, you know what? I'm going to use a system user for everybody that comes into my blockchain backend, and that system user is going to run all the chain code, and it's going to know that it came from my organization, but it might not be tied to the individual. Right, and then if you need to manage authentication of the individual in the application, it's your typical LDAP, directory lookups and etc. So it can be different mechanisms.
I think that's all the question. But before we go, what do you think the number of transactions for Fabric going?
Well, so we did just publish a very, very well reviewed and thoroughly reviewed paper, actually not just published, this was a few months ago now, that has Fabric transactions benchmarked at around 3,500 transactions per second on non-super intense hardware. So this is relative commodity hardware. So you can look that up. That paper was published academically. So
what's the set of the data on?
They went actually through a token. So they built a token-based solution, and so the paper will go through the details. I don't remember the specifics of the actual implementation, but takes you through exactly kind of what the use case was and how they structured it, and it shows you all of the performance graphs. But last I heard was about 3,500 transactions per second. Certainly the applications that you build may not require 3,500 transactions per second, and to get there requires a little bit of knowing what you're doing and to make sure that you understand the knobs and dials to tweak. But that I think is a point in time and is looking to grow even beyond that going forward.
Okay, so thanks, Curtis.
My pleasure.
And this was Off the Chain, on blockchain show on YouTube, discussing everything technical, no ICOs. See you later.